Hey, it's Tom, and today I'm going to show you how to use CreateML and a couple other tools to create an object detection model from scratch. And then we'll export this model and use in iOS app to detect objects on provided photos. So let's jump to the code. Okay, let's start with collecting data. So at first you definitely have to decide what kind of objects would you like to detect on photos. In my opinion, for this tutorial, we will use the three most popular road signs in Poland. And there are two important things to remember while using CreateML, because we will use CreateML to train an object detection model. So the first thing is, according to what Apple says, you should collect at least 30 samples of photo of each object you would like to detect. And of course, the more photos, the better. But for proof of concept and for this tutorial case, we will just collect 30 photos of each class. And the second important thing is to try to have balanced amount of data for each class. So avoid situation in which you will have 100 photos of one class object and only 50 photos or even 30 photos of different object, because that can have an impact on training results, and the model will be just worse. Okay, so at first, how to find training data. So in my case, I think the easiest way is to use just Google and try to find images called road signs in Poland. Then we can check what's the exact name of particular road sign we would like to find, and then we can try to find it using Polish words like so maybe P14 is not a good example, but still, yeah, you just have to collect a lot of data, so we can just download those photos from internet and collect in one folder. And then we have to switch to other important part of preparing data, so labeling. Okay, so you collected a lot of data. In my case, it's close to 90 photos, because we're going to train object detection model for 3 classes, and we'll provide around 30 samples for each class, so that gives around 90 photos. And the problem is that Apple doesn't provide any tool which allows us to label data, and we definitely have to label data for training. But luckily there is a solution, free solution, which is pretty important. So there's a free solution built by Nick Burdakos. I hope I pronounce it correctly. So this is a free tool available online, and there's a whole tutorial how to use it and how to create an account on HackerNoon. Of course, link to this article will be below this video. And when you will set up your account, you can just log in using IBM Cloud, and then you can, for example, create new project. I already have the road sign project, but I will show you how the process looks. So road sign 2, okay. All photos are stored on IBM Cloud, and there's a free tier around 25 gigabytes, I believe. So, okay, we're going to create a new project. Okay, that took a couple seconds, so I just cut them. And then we have to decide what kind of annotations we'll use. So in our case, we need localization, and we can drop a couple photos. Maybe a couple different photos, like, yeah, let's select a couple photos, drop them here. They will be imported. Okay, we'll use that later. And then it's pretty simple. So we just annotate it, then we create a class. That's D14 if I'm correct. Yeah, I might be wrong, but then it will be much easier for you to label other photos. Yeah. For example, let's call it stop. And then if you are annotating other photos, you can select the default label, and if that would be the same road sign as in the first photo, that would be automatically labeled as D14. However, it's not D14. Okay, so let's go to my project I really used. There are, as you see, 79 photos, and the labels is 30 labels for A7, 36 for B20, and 30 for P14. And as you see, yeah, there are even photos of multiple road signs, and that's definitely not a problem. You can definitely use one photo with a couple different classes of objects which will be detected. And then when you will label all your photos, you can just simply export it as for CreateML format. You can also export it to different formats, but in our case we'll use CreateML. And then when you will download it, it will look like this. It's the same list of photos, but with annotations JSON file. Let's open it with Visual Studio. Yeah, so as you see, this annotations JSON file contains a list of JSON objects, and each object is one photo, and each photo contains a list of annotations. So they have label and coordinates, and please keep in mind, that's pretty important, that X and Y coordinates are not the top left corner of the frame of the object. They are the center of this detected object. So if you will try to check them, you might be a little bit surprised. And of course there are some photos that yeah, for example, this photo contains 4 objects, so the list of annotations is just longer. Yeah, so that's the complete format. So there's a list of photos and annotations JSON file. Okay, so we collected and labeled data. Now it's time for training. For training, we'll use CreateML. So you just have to start your CreateML app, create a new project. In this case, we need object detector model. We should call it somehow. Road sign detector sounds pretty good. Save it. Yeah. And the cool thing is that it's simply drag and drop tool. So when we will download the directory with annotations JSON file from Cloud Annotations app, we need to simply drag it to CreateML, put here, and then just play train. Of course, I did it yesterday, so I won't train it right now because it took over 2 hours. So I will show you exactly the model I trained yesterday. That's this model. Yeah. And as you see, trained model is 63.5 megabyte. It took 2 hours and 27 minutes on 2017 MacBook Pro to train it. And the computer was unable to work on anything different. So the best way to train is just to start training, I don't know, when you're going to sleep, and just leave it for a whole night. Okay, the cool thing about the created model is that we can simply verify the quality of this model right here in CreateML, and I have a couple testing images which were not used for training. That's important. And yeah, we can simply drag them here, and yeah, as you see, we can simply go photo by photo, and it looks like the model is working pretty fine, and it's detecting even more than one objects of particular class on one photo, so that's pretty okay. So yeah, the next step is just to export the model. So we can either use share or just save it locally, and then we'll have to switch to the Xcode. Okay, we are now in Xcode. So as in one-shot learning video, it's just a simple app with one storyboard. There's just UI image view used to preview, and test photo button connected with the IB action. And the test photo causes that we show the UI image picker controller. And we have a delegate for this UI image picker, and we check if there is a photo, and if there is indeed a photo, we set a preview of this photo in our UI image view and call update detections. And that's the tricky and important part. So this method transforms the image into core image format, and then we use dispatch queue to run the prediction method on global queue to just not block the main thread and UI. So as you see, we have here a vision image request handler, and then we use that to perform the detection request. And detection request is vision CoreML request, so we are requesting the CoreML to use our provided CoreML model to predict on provided photo. So as you see, that's lazy variable. So the first time we use the prediction, it can take more time, but during the second, third, or any next try, it will work definitely much faster. So at first we have to create a model. So it's a vision CoreML model. We initialize it using the name that the model was saved, and then we create a vision CoreML request, and we provide also a handler for that, which is called process detections in our case. And this method comes back to the main thread, because we'll have to draw the detections on the photos. So where we are changing the UI, we definitely need to run it on main thread. And draw detections is it's not related to machine learning at all. It's a simply method that it's just drawing predictions on the UI on the UI image. So yeah, we can run the app. I hope that's proper simulator. Okay, yeah, that's the proper simulator, I strongly believe. Yeah, the proper photos are here. So we are selecting the photo, go through the prediction, and we just print the confidence for each class in the console just to see it. And as we see, the confidence is pretty high, and that's working for all photos. Yeah, it's 4, but it's E mantissa, so we have 99% confidence that it's a stop road sign. An important thing to remember here is that the coordination of the predicted box is starting in the bottom left corner, not in the top left corner. So that's pretty important to remember. So yeah, we just go through the whole process of creating object detection model from scratch. We collected data, we labeled that data, we used CreateML to create an object detection model, and in the last step we just imported this model and used in iOS app. So I strongly believe that at least one person will find this tutorial good. And as usually, thank you for watching. All links, source code will be linked below the video. If you have any questions, let me know down in the comment sections. I will be more than happy to help you. Thank you for watching. So see you next time. Bye.